So in 2.5, we talked about solving equations using the addition and subtraction. And we did things like x plus 5 is equal to 12. And here, since we had the 5 plus 5 here, and we had the variable on this side, we decided that we were going to subtract 5 from both sides. So if I subtract 5 from both sides, what do I get? I get x, this guy cancels out, is equal to 12 minus 5, which is 7. Or 12 minus 5, and then I do that and I get 7, right? Okay. So what's actually happening, and this is what a lot of the, when we talk about this kind of things in math, we say that I started with this, I end up with this, okay? So I started with this, I end up with this. So what we call this is we call this bringing the 5 across the equal sign, okay? So I bring the 5 across the equal sign, it becomes a minus 5, okay? So I moved the 5 over the equal sign, it became 12 minus 5. The plus 5 became minus 5. We can do this the other way, right? Let's say that I had a negative. Let's say I had a x minus 3 is equal to 7. Okay? So let's apply the same logic and see if it works. So if I move the 3 over, it was a negative, and now it becomes a positive. I have 7 plus 3, which is equal to 10, which makes sense, right? 10 minus 3 is equal to 7, okay? So we call it moving the number over, okay? All right, so that's so that's something that you can look out for, and something you can use, okay? We move the number over across, and when you're doing additions and subtractions, it becomes a negative number, okay? So let's go ahead and move on with 2.6. So who just joined us with the iPhone? Who is the iPhone?
That's me, Francesca. My computer
Right.
wasn't joining in. I don't know why.
Okay. All
I
right.
had a phone.
Okay. So now we're missing only Dino, Josh, and Lysandra. Okay. Let's move on with 2.6. In 2.6, we're going to do the same thing, but we're going to, instead of using addition and subtraction, we're going to use multiplication and division. So let's go in the middle of page 97 where it says, dividing each side of an equation by the same non-zero number produces an equivalent number. So in other words, if I have an equation that looks like 3x is equal to 12, I would divide both sides by 3. This 3 and this 3 would cancel out because I have one on top and one on the bottom, one in the numerator, one in the denominator. They would cancel out, leaving me with just the x. 12 divided by 3 is 4. So your answer is going to be 4. So your original question was 3x is equal to 12. So some number times 3 was going to be equal to 12. And that some number happens to be 4. And that's how we solved that. Okay? So the flip side would be this. What if I had some number divided by 6 is going to be equal to 10? Now, in this case, instead of dividing by both sides, I'm going to multiply both sides by the same number. Okay, I'm multiplying both sides by 6 because now the 6 in the numerator and the denominator cancel out. I'm left with x, so x is equal to 10 times 6, which is equal to 60, which makes sense because the original question was this, right? Some number divided by 6 is 10, that some number is 60, right? 60 divided by 6 is definitely 10, okay? So that's how you use the multiplying and dividing. So let's see if we can do the examples and see if we make this work. Let's go to example number 1. I have negative 6x is equal to 48. Okay. And again, my whole goal here is to end up with x is equal to something here, right? Okay, so I want to isolate the x by itself. I want the x by itself. So what do I have in front of the x? The negative 6. I need to get rid of the negative 6. The way to get rid of that, since it's multiplication, is to divide both sides by negative 6. So the negative 6 here and the negative 6 will cancel out. I have x is equal to 48 divided by negative 6, which is, since a positive number divided by a negative number, it's a negative number. 48 divided by 6 is 8. So the answer would be negative 8. Okay. Flip the page. Let's go to example number 2. Example number 2, we're going to have solve 9 is equal to w divided by 7. I'm trying to figure out what w is. Again, I want to leave w by itself. I want w by itself. In order to get w by itself, I'm going to have to get rid of this 7. And the way to get rid of a 7 in the denominator is multiply the numerator of both sides by 7. The 7's cancel out. I have w is equal to 7 times 9. Your answer is 63. Okay. Let's go on to example number 3. Example number 3. On January 4th, 2003, the SOHO spacecraft detected solar wind traveling about 2 million kilometers per hour. The sun is about 150 kilometers from the Earth. How long did it take that solar wind to reach Earth? So you have the sun, you have the Earth here, okay? The solar wind is going to travel from here to here. It takes 150 million kilometers. And the wind is going to travel 2 million kilometers per hour. So I'm going to have to do, since it goes 2 million kilometers per hour, the distance that it's going to travel in each hour is 2. So if I have 2 times, I don't know how many hours, right? 2 times how many hours is going to be equal to 150, right? And this is what I'm trying to solve. Again, I want the x by itself, so I need to get rid of the 2. The way to get rid of the 2 that's in front of it is going to be divided by 2. Now you can have this and this cancel out. X is equal to 150 divided by 2. 75. So your answer is 75 hours. Okay, 75 hours. Yeah. Any questions on what we talked about so far? Any questions on what we talked about? No questions? Okay.